This mini lesson is going to focus on the simple machine known as the wedge. The wedge basically functions as a moving inclined plane, and it can actually be thought of two inclined planes basically sandwiched or placed together. It uses force to come between two things, and it typically can do three different types of work. One would be to connect things. An example would be the nail. It could be used for splitting things. A very common example would be the axe. Or it can also be used for tightening, and a good example of that would be the doorstop. Each of these represents the use of a wedge. As with every single simple machine, there is a force-distance trade-off. The wedge is going to work just like a ramp. The narrower the wedge or the sharper the point, the easier it is going to be to drive it in and push things apart. The trade-off, though, is in order to get something to split apart really wide, you have to push the wedge a long distance. So if you look at the picture, the amount of the wedge that I've got in there so far, the actual load is not pushed apart very far. To get that load to be pushed apart, that wedge needs to drive down deeper so that we can actually get that separation distance defined by the base of that wedge. The longer and thinner a wedge is, the less effort force is needed to overcome the resistance force. Think about a simple kitchen knife. If you have a dull kitchen knife, that's because that wedge basically has been ground down. The sharper the knife, the easier it is to cut through food because you got a long, skinnier wedge once that is sharp. Another example, imagine you're trying to put a nail into a piece of wood. What's easier, a long, skinny nail or a fatter nail? Hopefully you know from experience that the skinnier the nail, the easier it is going to be to drive in because it's got that, again, force-distance trade-off. The skinnier the wedge, the less effort force is going to be needed. So let's take a look at how to calculate the ideal mechanical advantage of a wedge. Just like every single simple machine, the ideal mechanical advantage is found by taking the distance of the effort divided by the distance of the load. What's different is where we take these measurements. The distance of the effort is going to correspond to the length of the wedge. So as you are swinging your axe, you would have to go down this far to actually split your load or your wood apart. The distance of your load is the distance traveled by the resistance. That's going to correspond to the width of the wedge, in this case shown by the letter H. How far apart you're able to move your load is what we define as the distance of the resistance. Using the symbols in the picture, then, we're going to take the length of the wedge divided by the height or the base of that wedge to find our ideal mechanical advantage. In this particular picture, we're going to take 10 divided by 3, and we would get a mechanical advantage of 3.3. Now there is some debate about whether the length is perpendicular to the height or the length represents the sloped surface. Using trigonometry, you could figure out how long the wedge is based on the height and that perpendicular length. Both methods are actually used, and there's very little difference in the calculation of the IMA with either measurement that you choose to take. So for example, if I use my length to be the length of the slope, I would get an ideal mechanical advantage of 3.46. Notice it's only a little bit over 1/10 of a difference between the two measurements. So the moral of the story is it really doesn't matter which length you use. The mechanical advantage is going to be close enough when you calculate it. The actual mechanical advantage is still going to be found by taking the force of the load divided by the force of the effort. Using this same wedge picture on the right, the force of my load is given as 700 pounds. It took 250 pounds of effort in order to move them apart that 3 inches. 700 divided by 250 gives us an actual mechanical advantage of 2.8. The efficiency of the wedge, then, is your actual mechanical advantage divided by your ideal mechanical advantage. And in this particular scenario, it would be an 84% efficiency rating. Not too bad. If you have any questions about the wedge, please make sure you ask them in class.